Students, yesterday we discussed about some of the reactions in which we have added CHO group to the benzene ring, that is the activated benzene ring, and one was the diazonium coupling reaction in which different kind of dyes has been synthesized, and the wide applications of that reaction has also been discussed. Today we will discuss the remaining reactions of this particular chapter, aromatic electrophilic substitution reaction, and in that series the first reaction is the Bisclair-Napriansky reaction. This reaction is a very important reaction as far as synthetic utility is concerned, and this is basically a tool or a reaction that is used for the synthesis of dihydroisoquinolines, and from where these dihydroisoquinolines have been synthesized, that have been synthesized from beta ethylamides by using condensation reagents. Different kind of the condensation reagent that can be used for this reaction, that includes the phosphorus oxychloride, that is POCl3. It may include ZnCl2, and it may also include the P2O5. So in this reaction we synthesize dihydroisoquinolines, and the dihydroisoquinolines further can be aromatized to isoquinolines. So basically this is a synthetic tool by which you can prepare isoquinoline. This is the substrate of your reaction, and this is basically phosphorus oxychloride is the condensation reagent basically we use for this reaction to happen, and this is the dihydroisoquinoline that you have synthesized during the course of this reaction. When we talk about the mechanism of this reaction, mechanism is very important, and it generally involves two steps, in which the first one is the dehydration step. In the dehydration step, the C double bond O group is being eliminated out, that is water has been eliminated out during this course of reaction. So we basically use the dehydrating reagents, and after dehydration, the dehydration will be followed by the cyclization, and further if we want to convert dihydroisoquinoline into isoquinoline, then it will be further followed by the aromatization process. So how the overall mechanism will take place, I will show you through this slide. So this is your substrate. To this substrate, first of all, the condensation reagent that you have selected for the reaction, that is phosphorus oxychloride, will react. And how this reaction will happen, the nitrogen is having the lone pair of electron. So first of all, this lone pair of electron on this nitrogen will come to this particular carbon to form N double bond C, where the N will carry the positive charge, and this particular bond between this carbon and oxygen will now attack on this particular phosphorus with elimination of Cl negative. So in the first step, this adduct will be synthesized. After this particular will abstract H positive, and H positive, after removal of this H positive from this one, from here the H positive will be eliminated out, and after this elimination of H positive, this particular group will be eliminated out from this one, forming N triple bond C, and N will carry the positive charge. So basically this is the dehydration step in which the carbonyl oxygen is being eliminated out from the substrate. Now it will be followed by cyclization reaction, and cyclization will takes place at para with respect to this particular group, that is OMe group is attached. So this is basically activated ring. So when this electron pair will attack on this particular carbon with movement of electron, this electron will attack on this particular carbon, reason being with the migration of electron because the nitrogen is carrying the positive charge. So electron will be moved from this particular carbon to nitrogen. So here cyclization will happen, and after cyclization the H positive will be eliminated out and it will get converted into this particular moiety, that is called as the dihydroisoquinoline, from which you can also get the isoquinoline, in which there will be a double bond between these carbon, that is this carbon and this carbon. So there will be a double bond here. So this is the Bisclair-Napriansky reaction for the synthesis of dihydroisoquinolines and isoquinolines. The next one is Pacman condensation reaction, Pacman reaction, and this reaction is a synthetic tool for formation of coumarin. And from where this coumarin can be synthesized? It can be synthesized from reaction between phenol and beta keto esters in presence of Lewis acid, that is AlCl3 is being taken in our case. So this is your phenol and this is your beta keto ester. These two react in presence of AlCl3 and will get converted into the coumarin. So this reaction is called as the Pacman condensation reaction. The mechanism for this reaction is basically, first of all, there will be trans-esterification reaction, then there will be keto-enol tautomerization. After this, there will be a cyclization, right? So first of all, there will be a trans-esterification reaction in which this particular phenol will react with this one and will get converted into this particular product. This one presence of H positive will be converted into enolic form. So this is your enolic form, and to this enolic form there will be cyclization, right? Means there will be a Michael addition reaction, and this particular bond here will attack on this particular carbon bearing the double bond with movement of this particular bond to this one, and this particular will abstract the H positive from here, and finally the hydrogen will be eliminated out from this one, H positive will be eliminated out, and aromatization will happen and will get converted into this particular skeleton. And this skeleton on further abstract the H positive in the this step, and after abstraction of H positive it will get converted into H2O positive, after which the water molecule will be eliminated out with aromatization will happen and it will get converted into finally this product, and this reaction is called as the Pacman condensation reaction. So synthetically this reaction is also very important reaction, that it form the coumarin by using the phenol and beta keto esters. Now the last reaction in this chapter is the Hoban-Hosch reaction, in which basically we use polyhydroxy aromatic ring, and that ring is acylated. And how that is acylated? That is now acylated by using the nitriles in presence of HCl and maybe ZnCl2, or maybe any Lewis acid we can take. For example, this is the reaction. This is your polyhydroxy compound, and the Lewis acid that we can take here, that may include the ZnCl2, that may include the BCl3, AlCl3, etc. And this is your nitrile. So COR group, that is acyl group, will be introduced on the benzene ring, that is ortho to this hydroxyl group and para to this hydroxyl group it will be introduced. The proposed mechanism for this reaction is, as we know that we are having nitrile, this is your nitrile RCN, and is carrying the lone pair of electrons. So first of all, as the reaction is being carried out into the acidic medium, first of all the lone pair of nitrogen will react with this H positive acidic medium and will get converted into NH positive. Ultimately, this is stabilized and this electron will move to nitrogen, and here is the generation of C positive, that is the electrophile is being generated during the course of reaction. So this is your electrophile to which the aromatic electrophilic substitution reaction will happen with the movement of electron from this one to this carbon, and then to para position attack will happen, and it will finally lose the H positive and will be aromatized and will get converted into C double bond NH and R. Now this nitrogen again will abstract the H positive and will get converted into C double bond NH2 positive, and finally the water molecule, the oxygen lone pair of electron will attack on this particular carbon with the movement of electron from C double bond N to nitrogen. So it is now being converted into OH2 positive, and then there will be proton transfer. And how the proton transfer will happen, that this particular proton will leave its electron to this oxygen, and the nitrogen lone pair of electron will abstract the H positive from this one. So proton transfer will happen, and ultimately the ammonia will get eliminated out, NH3, and then the bond between this oxygen and hydrogen will be shifted to this carbon and oxygen to form C double bond O, and ultimately it will get converted into C double bond O R group, that is acylated. So basically this reaction is acylation reaction, but this is not the Friedel-Crafts acylation reaction that was being done in presence of RCOCl and the AlCl3. Here we are not using RCOCl, instead we are taking the nitriles in presence of HCl and in presence of Lewis acid. So again this is a acylation reaction we can say. Now if we are talking about the Hoesch reaction, that this is a particular Hoesch reaction in which we are taking this activated benzene ring in which the R group may be a hydroxyl group, maybe OR group or NR2 group, and again this is your reagent that can be used for the reaction, and COR group will be introduced to the benzene ring basically. If we talk about this particular Hoban-Hoesch reaction, at that time we specifically use the phenols as our substrate, and in which we have more hydroxyl group attached to the benzene ring. In case of polyhydroxy group, the yields are generally good, and that's why we take the polyhydric phenols in our case, right? So this is called as the Hoban-Hoesch reaction, and that's all about your topic, the aromatic electrophilic substitution reaction. Tomorrow we will discuss the aromatic nucleophilic substitution reaction.